The year is 2100. The human population has exceeded the sustainable level of resources for the planet. The only way to support the rapid increase of the human population is to go beyond Earth. Since we don't have the technology for intergalactic travel, we can only consider the planets around us. But what would happen to humans if they reach the other planets? Would they be able to survive without the ideal physical conditions and no special equipment? Let's find out. And let's start with the center of our solar system, the Sun. If you were to set foot on the Sun, you would immediately be vaporized, as the temperature can get over up to 7,000 degrees Celsius. This is over 18 times as hot as a pizza oven. The vaporization would occur due to the excess amount of heat energy applied at the moment you were exposed to the sun's conditions. We can use the heat energy formula to find out how much energy you would be gaining instantly. Because our bodies are 75% water, we can assume that the energy constant would be 4,200 joules per grams degree Celsius. With the body temperatures rising from 37 to over 7,000, you would get approximately 2 quadrillion joules of energy in a matter of a second. The next stop will be Mercury, the closest planet to the Sun. Mercury at all times has a hot and cold side of the planet. The hot side is about 420 degrees Celsius and the cold is about negative 173 degrees Celsius. Therefore, if a person stood directly on either side, they would either be burned to death or freeze to death. This being said, assuming you could perfectly straddle the line between hot and cold and rotate so that neither side was burnt or frozen, you would be able to survive as long as a person can go without an oxygen. Due to the lack of thick atmosphere, the extreme low pressure it would also pose an issue, because the boiling point of water would drop from 100 degrees Celsius, that is on Earth, to less than 37 degrees Celsius, which is the internal temperature of humans. The temperature of boiling point for a liquid is determined when its vapor pressure is equal to the pressure of the gas above it. This means that the lower the pressure of the gas will lead to the lower boiling point. Our blood is made up of about 92% water. This means that the low pressure would cause your blood to boil, and as your arteries would not be able to handle the rapid expansion, they would explode. And the decrease in boiling point is illustrated by the graph shown. Our third stop would be Venus, the second planet from the Sun. Venus maintains a constant surface temperature of roughly 465 degrees Celsius. This, coupled with the lava that surrounds the planet and the acid rain from sulfuric gas in the atmosphere, would, according to the heat energy formula, cause you to gain 107 trillion joules of energy. This swift increase of energy would burn a person to death, making the lifespan on the planet be less than 10 seconds. The next stop is Earth, the third planet from the Sun. Earth is the only planet in our solar system on which life has been confirmed. This planet houses the perfect conditions for life. Due to this, a person can comfortably live on Earth until they die of old age. Mars, the fourth planet from the Sun, is our next stop. Temperatures on Mars can vary from 20 degrees Celsius at the equator to negative 153 degrees Celsius at the poles. This means that though a person may freeze to death in the colder environment, temperature would not be a factor on most of the planet. Instead, a person would experience extreme discomfort from the atmosphere, which would cause any water or liquid to evaporate and then would suffocate. This means that the person would be able to survive for as long as a human can go without oxygen. And another problem with Mars' condition is the pressure. The average pressure of Mars is 6.1 millibars of mercury, whereas the Earth's pressure would be measured at 1,013 millibars of mercury. This makes the boiling point of the water too low for the human survival. The last four planets in our solar systems are the gas giants Jupiter, Saturn, Uranus, and Neptune. Since they are enormous in their masses, we can use Newton's law of universal gravitation to find out that human body will be crushed by the gravities which our body cannot endure. Mass of the planet times the body mass divided by the distance between the objects shows that there will be too much gravitational force applied to our body. As humans typically require the air that they breathe to contain about 7% oxygen, even if you are able to construct some sort of platform on any of the four gas giants that would keep you from being sucked into the middle of the planet and crushed by the pressure, you would not be able to breathe the air and would suffocate. All four gas giants have over 90% hydrogen gas and 10% combination of helium, ammonia, methane, and sulfuric gases in their atmosphere. This results in the lifespan of less than 10 seconds on each of them. So in conclusion, there is no other planet in our solar system that is suitable for human life, which means that we need to take care of the planet we already have.